So I don't bore you guys with the definitions. So please go to this link. And this is last week I shared with you an experiment, reproducibility. This is the same Git, what I've changed many parts of it. So it's very different from last time. So please clone it on your local computer if you have Azure SDK installed, or use the notebooks.azure.com. That doesn't require any installation or anything. So you can go basically to notebooks.azure.com and log in with your free account and clone it there. So the way we wanted to basically proceed is I first go through this, because last week I was going through the labs and you were also following. It was hard to catch up. So now I go through the lab. Please pay your attention here. Then we're going to give you about 20 minutes or 15 minutes based on the lab, and then you focus on your environment and you reproduce that result on your computer. That we found it is easier for you and us to basically follow each other. So again, this link is provided within the PDF file that I send it to you. So please go ahead and find it. And beautiful. So again, please pay attention here, and then we will give you about 20 minutes to basically work on it.
Can you blow it up?
Absolutely. It's too small, yeah. You can actually do that too. Yeah. So if you want to see it, please do not spend a lot of time on your screen, but if you want to see it, please get to this repo and open up one file, which is reproducible experiments. Open up this IPython notebook. There's a problem with GitHub. Sometimes in the past 2 years, sometimes had this issue. It sometimes fails to open an IPython notebook. So if you had this problem, clone it on your local computer on Jupyter, like this time, it failed. So use the notebooks, again, on Azure, free notebooks, or clone it on your local computer and use Jupyter to basically kick it off. You can also use VS Code to see what's inside it. So again, it has an internal mechanism to read IPython notebooks. So first of all, I want to basically create a resource. Last week, I went through that to show you how you can do it, but again, I wanted to do it again to show you how you can basically create it. You go to the portal and you search for, thank you, that's a great way to keep track. So first you go to the portal and you search for search for machine learning workspace. This is my free account that I created to see if I can keep track of it or not. You search for machine learning, and then you will hit on it. If you have already created one, do not create again. Just keep only one. It will become harder to follow again later. So you hit create. You will be asked to provide some information, and you'll be done. So again, coming back to this workshop. So once you have created the service, when you go to your home page, you basically will see everything you have created. So I've created this one, which is called First Example. This is the workspace that I created. That's a terrible name, but that's the name that came to my mind when I was creating that. When I hit on it, it basically lands in the overview page. In the overview page, I can get some information which I'm going to use for myself in the notebook environment. So the information needs to be replaced here. So I need to basically copy this, which is a subscription ID. I bring it here to the notebook. The rest also should reflect exactly what is happening there, like the workspace name, the resource group name, and the location. I deployed it in the US, West US 2. So that's the important thing you need to get from your portal to your local computer or your development environment, basically. I will zoom in a little bit more so you can see and follow better. So within this example, throughout this exercise, to be loyal to my promise that do not use a complicated machine learning problem. I didn't want to use a complicated machine learning problem. I want to solve a MNIST problem, build an MNIST basically classifier on an image to just we do not spend time on the actual problem. We just see how the flow works basically. And then there's so many complicated repos I showed with you that you can go and reproduce that for complicated problems. So the first step is basically I download some images from Jan LeCun website, which are like, these are the MNIST 60,000 digits that are downloaded to my local computer. If we want to see how they look like, they basically look like this. There are like about 60,000 of these. I want to build a classifier and be able to predict for a new image what is the digits inside that image. That's basically a hello world example in many of the ML problems. So I downloaded it, then I import a bunch of packages to be able to Python libraries and also be able to work with the Azure SDK, ML SDK. So this is the important part that I will basically log in to my workspace. So by running this code, if I have everything defined well, so I haven't run this. So if I have defined everything well, then it will basically log me in to my portal to make sure this is me that I'm trying to, because I already logged in, it doesn't ask me to do that. It gets you a WS object, which is referring to the workspace. So every time I work on it, I'm basically working on that workspace that I showed to you within this, within here. So basically, the workspace that I created, which was called first example, looks like this. And every time I actually created an object called WS, which is pointing out to the workspace, which is in the Azure, right? I'm coding on my computer, but I'm talking to that and be able to control it. So there are two ways to create runs. Do you remember, again, those trials within the experiment? One is interactive way. For instance, you're basically working on a data set and you want to interactively work on it. One way to track that, there are a couple of things you probably want to track, like the size of the data set, the distribution, the way it basically looks. And every time you change that, you basically may want to change it. So going back to that diagram of the experiments, I want to basically create one high-level object of the experiment, and within that, I want to create multiple runs and be able to track those. So in order to create a high-level experiment object, I basically call the experiment class instantiated with some values. They provide the workspace and the name. And then in the experiment object, I do have the access to that experiment within my workspace. So every time I work with it, I basically am able to log my work. So within experiment, you can basically create any number of runs you want by calling the start logging. Again, this is the interactive way. There's another way that I will show you. When I call this, basically what it does, it will create a trial within the experiment, and it will point it down to the object run. Because of the internet speed, it takes a while, and I also need to connect my charger while it is running. Thank you very much. Perfect. Now it's telling me that the status of the run is running, right? So it means that it's active. So when I get the details, so what it does, whenever I run something, it fetches the head of my Git repo. If I have a Git repo, it will get the head, and head means the latest current status of my Git in my local development environment. It gets the active branch, and also if there is a remote repo, it basically connects to that. So I will have the situation of my code, so I can basically point out later on within the GitHub repo. So you can basically get your run later on by basically providing this to and provide the run ID. I don't call this. And yeah, so again, every time I'm hitting run is pointing out to the Azure, right? There's a service in Azure which is keep tracking of that. In order to see exactly what's going on there is a class called run details, which basically visualizes me what's going on within that. So if you have installed the widgets on your and notebooks in the extension of the Azure ML installation, you'll be able to run it. If not, again, notebooks doesn't need any configuration. So what it's showing me is the status of the run in the cloud. So it streams the data from the cloud to my local development environment, shows me exactly what's going on there. Now, I want to actually start logging some metrics. So these metrics can be accuracy number, can be like if you have an epoch or something like that, you can basically keep track of all of those like accuracy numbers, which is or the changes within the accuracy within the log, or anything else which applies to your problem. But let's say I basically start to log some values under the name metric1. So what happens, it basically starts to keep track of that. Again, we'll save it there in the Azure, and then we'll sync it back to me. Again, I will be able to keep track of that there, and it will stay always there within this run, unless I go and delete the entire resource, but it will be available. Like there are multiple types of like logs that you want to log, like list, row, image, and etc. I don't want to spend a lot of time there. But again, going back to the actual problem, I have downloaded some images, if you remember. Those are some zip files, which I now have to unzip the files, which inside are so many images, and then convert them into NumPy arrays. And in the conversion, I want to just run some normalization, normalize the data to have my model works better. So I import this library, which is available on the GitHub repo. And then by running this, what it tells me is that basically inside these, it will have the NumPy arrays of the normalized images. So like by log image, I basically will log this image within the, again, my run experiment, right? Or like tables and other stuff. So I run this, but then every time you want to get the logs, you can run the metrics. So it will tell you what type of metrics you have collected so far. Again, that's easy. Now we get to the data sets. So now we have collected the metrics. Now I want to be able to version and control my data sets. There are two types of data sets within Azure ML that you can basically control. One data set is called, one type of data is called data store. So do you remember I told you that when you create an ML services, there will be a default storage account deployed within the ML services. So that storage account is a default environment, which you can basically get and save your data inside. So
is it like S3 bucket?
Similar to S3 bucket, exactly. So that storage account is a like general purpose storage account, which you can save image or anything else, or CSV or any file, which by default is like that. But then you can connect it to like SQL type databases or like Databricks, Data Lake, or etc. But like for this purpose, for this example, I just use the default storage accounts. So the default storage account is saved as workspace, blob store. There is a dedicated UI for the ML services, which is under ml.azure.com. If I open it, I actually can see these data stores, and I can also introduce or add new data stores. And what these data stores are, these are basically keeping the connection or the reference point to those storage accounts. Like for instance, if you are having SQL Server or Databricks DBFS, there is a connection string which you need to have to be able to talk to those. So these data stores keep those credentials to be able to talk to those data stores. You can register and introduce new data stores, but there are, of course, some default data stores here. So if I go to data stores, you see one blob data store, and there's also one file which gonna ignore it for now, because of the time. But that's different type of a storage account. But yeah, within this ml.azure.com, if you go there, you will be able to see all of them, and we can basically introduce or add within the SDK or here. So now I have access to the data store by calling this. So the DS object is basically pointing out to the default data store, which is this blob of storage, which is, again, provisioned automatically behind the scene when I created the workspace. Again, this is the line. If you want to introduce new storage account, you can basically run that. Now, what I want to do, now I want to upload everything I downloaded from the Yanlikun to that external data store, right? The reason I want to do that is, again, to separate everything from each other. Like previously, you had to, you would develop everything on your local computer, have your file and everything here, but now I want to separate these two. I want to have a storage to keep my data, and also have a different computer environment to basically run my code and connect these two if I need it. If not, I don't want to have the data within my computer environment. So by the upload function, basically I load it there, and then I will be able to basically load the data into this location of the storage account. Now, if I want to show you what that actually looks like, if I can go to the portal, search for the, within the workspace, if I go to the options or properties, I'm basically able to see the default storage ID. So, right? So within here, it tells me that the storage names is like this. So if I go inside, I will be able to basically see the file that I uploaded through the code here. So within the storage, there's a concept called containers, similar to the buckets in the S3. So these are like logical folders within your storage. So I go to the containers, and I will see these. So the default storage account is basically pointing out to this container. So again, the data stores point out to a container within a storage account. So the MNIST data is basically located here that I just uploaded right now. Pardon me?
It has nothing to do with Docker.
The name is the same, but nothing to do with each other. Yeah. Yeah. Container is, yeah, that's like a logical folder within the storage account. Yeah. Similar to the buckets in the S3. There's also a different concept of data, which is called datasets. So the data store was the connection to an actual data service, right? But data sets are a reference to those or anything external, like S3 location or something in the GCP that keeps track of these references. So let's say now I want to basically create a data set and point it out to this file, which is available in the internet. This is an open data set. And then I will be able to basically access to that and be able to create a reference point to this data source. It can be, again, within the Azure Data Services or outside of that. And every time I access it, basically, it will be streamed to my development environment or to the compute target that I described, like single node or cluster, whatever. You'll see it later on. So now I'm basically connecting to this storage and then getting that back to my local computer. One of the good points of this is basically, so now you see that I got it from internet and it get like displayed here as the head rows. Something interesting about this is that I can basically version this reference point. And again, it doesn't version the actual data, it versions the reference points. So when I hit create or register, it basically creates a new version of this reference point to this data store. So again, going back to the portal, I can again see, do you remember there was a data store and then there's a new concept which we're discussing, the data sets. So within datasets, I'm actually able to see the dataset that I just registered. I already registered before, so you will see multiple of them. It will take time, I will go back. But every time I register this, it will be registered under a new reference point. So the good point of that is that I can basically point out to a particular version of this data reference, going back or forward, or I can basically and also can find a lineage in the past. Yes, please.
It's getting here.
Thank you.
But the data itself can change because it's external.
Exactly. So right now, it doesn't do the auto copy. So you can copy the data if you want to somewhere to keep the lineage, like manually. Or the good practice is that it's better not to change the historical data. But if it is changed, this doesn't keep track of that. And also, if you remove that, it doesn't help you to go back to the history. It is only the reference to that data store, not the actual data.
So then that applies as well as to the external data source that you have there too?
Exactly, yeah.
Okay.
So right now it is pointing out to an external data store, but I can change it to a blob storage on my local or SQL Server, for instance, table as a new Titanic DS name. So it will be two different data for basically reference points. If I change in the future, it will be again changed. Also, what I can do to keep the version is most of the times if you're working on Spark problems, they are partitioned based on some sort of date ranges, for instance, as a Parquet files. So you can regenerate basically the locations from first and the end, and then access to those and fetch them as a Spark data frame. Like this does the Pandas data frame export, but it can of course do the Spark data frame, which creates a Spark data frame out, and then you will have basically the first and the end of the data, which was if anything changes in between, which is not a good practice, it will not basically preserved here. Yes, please.
I'm trying to understand what you're doing here. Are you showing us data store and data set? Because the data in these two cases have nothing to do with each other. This one is Titanic, the other one is something.
Yeah. This is basically, I want to show you how the tabular data is located, and I will show you basically how the file is located. Yeah, that's exactly what I wanted to just point it out right now. So the data sets can be tabular and file based. So within here, I can basically, I registered that, and within here, I can basically connect to the data store that I just saved within the data source. If you remember, DS is referring to that data store. I'm registering a data set with the reference point to the file that I uploaded as part of the MNIST, right? So this, again, is pointing out to that. So every time, basically, I'm fetching this, I'm generating the reference point to this data store, which I already defined before. And again, if I go back here, you see these are different versions of that, and I can go back or forward within any of these data sets. If you save it multiple times, the same name, it will be versioned multiple times.
So basically, the idea is you don't touch the data store itself, but you just keep creating a reference version of that, and you call it data set.
Exactly.
So,
yeah.
A quick question. So there was a command ds upload, right? So this MNIST dataset. I couldn't locate it through Azure portal or through ML portal. Could you explain again how to?
Yeah, sure.
Where it is?
So, so when you upload it, it goes to the default data store, right? So the default data store is basically located here. So don't you mind if I within that break, I just come to your laptop and show you how you can do that? Yeah. Just want to make sure that the concept is explained, and then we will go through that. Yeah, it will get more clear when you do it yourself. Yeah. So now I basically can create that, and similarly, I can create the same kind of these are the files that I downloaded on the MNIST. It can be pointed at directly to the web store instead of the one that I downloaded here. So these are the two main versions that you can basically version the data reference. But if you have to copy, you can do it, of course, through the copy activity of the Azure yourself manually. So that can be like another, like similar to glue code. Basically, you need to like glue the codes together to basically do that, but it's not like a standard way of doing things. Especially if your data set is large, like many of cases like terabytes or something like that, copying every time you run is very expensive, right? So it's better not to really copy that. And right now, there are not a lot of data versioning technologies available. I will get to that in a bit. But yeah.